Right, so this is Unit 1, Lesson 17, working with rigid transformations. Our learning goal is let's compare transformed figures. Now remember, rigid transformations include translations, rotations, and reflections. So let's look at the warm-up. From here to there, line CD is the perpendicular bisector of segment AB. Okay, what does that mean? Let's talk about it. So if CD is a perpendicular bisector of segment AB, that means the length of from A to M, right, for that segment, is going to be the same distance or length from as to B to M. So those two segments are the exact same length. M is in the middle. It's the midpoint between point A and point B. Now, they say find each transformation mentally. So first one is a transformation that takes A to B. So A will have to map on to B. And there might be more than one transformation. So go ahead and just pause the video and think about which transformations could get point A to map on to point B. Okay, so hopefully you paused it and you got some ideas. Would a reflection of point A across segment or line CD work? Yes, right? A reflection would work. What about a rotation of point A around the center of rotation on M 180 degrees? Would that rotate A all the way over to map onto point B? Yeah, that would work. What about translation? Could you translate up and to the right until point A maps onto point B? Yeah, that would work. So you actually have some options there. You can knock out all three rigid transformations to do that. Let's look at the next one. A transformation that takes B to A. Well, would you agree that if we were able to take all three of those transformations, right, reflection, rotation, and translation for mapping A onto B, that you could do the same three transformations except the other way, from B to A? Right? Could you reflect B over line CD to map onto A? Could you rotate point B around M 180 degrees to map onto A? Could you just translate down to the left along that line AB until you get to A, to map B onto A? Yeah. So you could use the same three transformations, except you're going the other way now from B to A instead of A to B. Let's see, a transformation that takes C to D. Now this one's a bit tricky, right? Because if you think about reflections, we don't know for a fact, nothing was given to us that from C to M and M to D, right, that those two segments are the same length. And visually, you can see it. It doesn't look like it, right? So there's no guarantee there. So can we do a reflection? Can we do a rotation? Well, the distance between C and M to D, right, would that be the same after a reflection and rotation? No, right? So if you were to reflect point C over AB, right, the segment AB, C is going to not map onto D. It's going to be further out, over here where my cursor is, right? C is going to land over here, not on map onto D. That won't happen. Same thing with rotation. C will rotate around point M, but it'll still be a little too far out and won't map onto D. Now, translation could work, right? If you do a translate point C along the segment C to D, you could translate down to the right and land on D. That's fine. But the other two wouldn't work. Rotation and reflection wouldn't work. Okay, so that's a very peculiar situation. D to C. Do you agree that, well, we already talked about going from C to D. Now we're just going the other way. Does the same situation play out where rotation and reflection don't necessarily work? A translation, though, will, right? So if you translate point D along D to C, right, up and to the left until you get to C, yeah, that would work. But the other two wouldn't work. Rotation, reflection won't work because the distance, again, from C to M and M to D are not the same. Okay, so that's something to note. All right, the card sort, we can do that later on with another activity, so don't worry about this one. This one is very healthy. All right, so 17.3, reflecting on reflection. I see what they did there. So this kid, Diego, he says, I see a reflection that could take RSTU to R prime, S prime, T prime, U prime. So basically the blue figure onto the image of the green image, okay? But I'm not sure where the line of reflection is. Ooh, we do need a line of reflection. Do you see it? Take a moment, and just try to see it visually in your mind. Now, if he's not sure where the line of reflection is, we do know that reflections, right, maintain distance from wherever the line of reflection is. So if I was to have a line, right, with a designated midpoint, and I'm trying my best here to get that to map onto, do you agree that the distance is something to acknowledge for each point? Let's say from U to U prime. So I'm using the midpoint tool here. And do you agree that if I was to do a reflection, right, the line of reflection would have to be based upon the midpoints of the distance of whichever vertices you're trying to work with here. So let's see, trying to map onto the blue one first. There we go. So do you see that? Right? Because if he's not sure where the line of reflection is, it might be because he needs to take into account the distance between the vertices. So this reflection would work. His line of reflection would have to be using the midpoint between S to S prime. Right? I wonder if there's any other tools I could have used. Yes, let's reset the tools. There we go. What's this? Is this oh, what is this? Oh, this is interesting. I'm just playing around with the tools now. Oh, it's a perpendicular bisector. That's what it is. Interesting. So do you see how the line of reflection, like it wouldn't be here, right? But it would be in the middle between R and R prime. Okay. So again, just to kind of show you what that would look like, here's the reflection tool. Okay. I know I need to reflect RSTU. Diego's not sure where the line of reflection would be. All right, maybe he's guessing. He's like, maybe it's here. All right, it's a little off if he chooses that. But if he was to line it up better, and quite honestly, this tool does spoil you a bit because, as you can see, I'm guessing and checking. But if you want to be very exact, my recommendation is to find the midpoint between a couple of your vertices or all of your vertices if you want to be very cautious. So between S and S prime, right? There's the midpoint. And as you can see, the midpoint does go through the line of reflection, or the line of reflection does go through it, which kind of validates why my line of reflection is where it is. And I'll do the same thing with another point, U to U prime, like I did last time. You could even try a different point. Like I didn't do T to T prime, but I can. So let's make sure I'm trying to be as exact as I can. There we go. And as you can see, the midpoint is right there, and it's on the line of reflection. So every single vertice should be like that, where its midpoint from one point to the other, the midpoint will be on the line of reflection. Okay? So that's just something to note. And as you can see, I'm just having fun right now with the device. So as you can see, each point, right, each vertice from U to U prime, T to T prime, R to R prime, S to S prime, their midpoints really do help out in finding your line of reflection. So that's how Diego could do this. Okay. So our summary, working with rigid transformations. If two figures are congruent, right, we can always find a rigid transformation that takes one onto the other. For example, from ABC, right, ABC to D, or in this situation, DEF. Yeah. So looks like they're giving us those two triangles, and they're just saying there is a way to describe a sequence of transformations without guessing where the line of reflection might be. Okay, so let's see. It looks like what? What do they do here to get from ABC to this red image here? Do you agree that could be a reflection? Do you agree that could also be a rotation? What do you think? Okay, so let's see what they did. So the goal is to take image of E onto B, right? So we're trying to get B here to map over to here without moving. All right, let's make sure we read this explicitly. Then we want to take the image of D onto A without moving E and B. All right, so perhaps they did a reflection here. Okay, because if they did that, B and E won't move, right? B will stay where it is because it's going to be on the line of reflection. Without moving any matching points, we can start with a translation. So they translate up and to the right, right? So the red triangle would map onto triangle DEF. And it looks like they're discussing some rotations. And I'll tell you what, just to be a little bit more thoughtful, let's show you physically what they're talking about here. So with this situation, all right, it's very similar. How about trying to get triangle ABC to map onto triangle DEF? There are so many ways to do this, right? We can do reflection about a line. In fact, I would have to create the line first, yeah? So if I had a line of reflection in between point A and point B, or I'm sorry, A and D, you see that? If I reflect triangle ABC across my line here, line GH, would this triangle ABC map onto triangle DEF? Let's find out. Reflect about a line, click on my triangle, click on my line of reflection. It looks like it. Looks like it maps on perfectly. So, could there have been other ways to do this? Of course. So one other way you could have done it is you could have done maybe a reflection. Let's try rotation for giggles. Okay. Let me create a point of rotation. Let's say here. Okay, point G. And what if I do a rotation? Let's see, rotate about a point. Click on my triangle. Click on my point of rotation. Counterclockwise, reverse of a clock. Sure, why not? And let's go 90 degrees. See what happens. Oh, look at that. Look at that. Right? Now we need to, as you can see, is this triangle A prime, B prime, C prime, is this symmetric to the triangle we're trying to map onto? Triangle DEF? Yeah, it looks back to back, right? Like there's a reflection, and the line of symmetry is this A prime, B prime line. So how about we do one more transformation, a reflection. All right, we'll reflect across A prime, B prime right here. Let me click reflect about a line, click that triangle there, and click on the line of reflection. Ta-da, right? So this is a sequence of transformations. First, we did a rotation. I noticed some symmetry. some lined symmetry, right? Linear symmetry, and then I just reflected across, right? So that was a sequence of transformations that worked well. Okay, that's about it. Have a beautiful day.